So here's my entry for the Hackaday Retro competition. I bought this Sinclair calculator with the intention of repairing it, and there were some problems with the keyboard which needed fixing, so I sorted that out and that worked fine. Unfortunately, the main problem turned out to be this chip, which is the main calculator IC, the brains of the calculator basically. So that was a bit sad, but I thought, well, I won't be beaten by that. So what I decided to do is to replace the innards, replace this chip with a more modern equivalent, and this is the result. So I'll do some more recording later about the innards and how it all works, but briefly, let's say I've replaced that calculator chip with an Arduino chip and written some software to emulate how the device used to behave. I haven't got a manual for this, so I'm sort of guessing a bit as to how it works, but it seems to work okay and does the job. So what would we do back in the 60s? Probably something like 22 divided by 7 is pi. Hey. And we can do 12 times 12 equals, you know. So you get the idea. It's basically a calculator. I've taken some liberties as well, so we can do a few more things. So if we use large numbers, let's say 100,000 multiplied by 100,000, is that right? Oh, no. And it moves into scientific notation, so and that works with large and small numbers as well. So really it does 9 digits of precision is held, and then it adjusts the exponent accordingly. Division by 0 on such a calculator would normally give an error message, but as I'm submitting this for the Hackaday competition, I thought I'd suck up to the judges a bit, and dividing by 0 gives a slightly more entertaining result. So let's open this up and see what the modifications look like inside. There are 6 plastic clips which you have to be careful with. But there we go. I'll just zoom in on this. Okay, and there you can see the innards and the changes that I've made to it. So the original chip, this what's it called, C595 chip, used to go there obviously. So I've removed that, put a socket in, so we're able to replace that if we ever get a functioning version of that chip in the future. And then I've constructed this PCB board which plugs in and takes its place. So effectively this is a miniature Arduino, like a bare bones Arduino. It just has this 80 mega 328P chip, a couple of decoupling capacitors, and the reset resistor is in there. And that's really all you need to get this thing to operate. I'm running it at the factory provided configuration, which is 1 megahertz oscillator, and brownout is disabled, and that means that we can run this down to quite low voltage. I've got it running successfully down to about 2 volts. This device takes 2 1.5 volt batteries, so that's well within the range. The rest of it is the same. One other thing I had to remove was the power supply. So the original chip takes 15 volts as a power supply, and that's generated by a sort of a miniature switching power supply effectively, which uses this coil here. And I found the simplest way to disable the power was to simply remove that coil, and then that isolates all the tracks, so I don't have to cut any tracks or whatever. And I'm just leaving that stuck inside the battery compartment there in case some future person might want to reinstate it. Really, I've tried at all times to minimize any damage and to make it as easy as possible to go back to the original state. So that's it. The capacitors, well, I've kept these 2 original chips, so there really is a couple of LED driver chips here. The second one doubles up as part of the power supply as well, but we can leave it in place. So these provides the 4 voltages, driving voltages for the LED display, which is this Baumar LED thing here. Here's a shot of the trace side of the PCB. You can see it's all nicely hand laid out or stenciled, however they did it in those days. Nice curvy traces. I've had to add a jumper wire, as you can see, to provide 3 volts to the Arduino chip. The original power supply was 15 volts, and there was no available place to put it in neatly, so I've added that jumper wire. The other awkward part of the firmware, if you like, is the digits, the pins from the chip that drive each of these digits also double up as inputs to the keyboard matrix. So it just adds some complications to the software, that you have to essentially draw the display segments and then blank the display and then read the keyboard, and so the software does it in a loop of displaying the number and then reading the keyboard. But it's quick enough to not to be noticeable to the human eye.